Good morning, everybody. Hope you all safe with a good health. With you, Ms. Dina Al-Badri, a physics teacher for grade 12. Today, we will talk about chapter 17, section 2. We will talk about curved mirror. In this section, we will talk about uh, explaining how concave and convex mirror form image, describe properties and uses of spherical mirrors, determine the location and the size of spherical image. Concave mirror. At the beginning, we'll talk about the concave mirror. If you look at the surface of a shiny spoon, you will notice that your reflection is different from what you see in the plane mirror. In the last lesson, we talked about the plane mirror, how the image is reflected and refracted from the plane mirror. Okay, the spoon acts as a curved mirror. It has two faces, with one side curved inward and the other side curved outward. The properties of the curved mirror and the image that they form depend on the shape of the mirror and the object's position. So, I have two factors affecting the shape of the image, which is formed from the concave mirror. This two factor is the position of the object from the concave mirror and the shape of the concave mirror. Okay, in this figure, did you see? In this figure, we show how the spherical concave mirror works. I have two lines. This line is parallel to this line. So, this red line is parallel to this principal axis line. Did you see? This line, which passes at the center of the mirror, of the concave mirror, we called it principal axis. The mirror had the same center, C. Okay, we called this point C, the center of the mirror, and the radius of the curvature is R. This is the radius from the point from or the distance from C and M. We called it radius or radius of curvature. At the sphere of the radius R. The line that passes through the line CM is called principal axis, which is the straight is a line perpendicular to the surface of the mirror and divide the mirror in half. Did you see? The line that passes at the CM, we called it principal axis, is the straight line perpendicular to the surface of the mirror that divide the mirror into two halves. The half 1, half 2. Point M is the center of the mirror where the principal axes intersect the mirror. We know that the sun is the main source of light on Earth, and the rays which come from the sun is parallel because it's very far away. All of the light that comes directly from the sun must follow almost parallel path to the Earth, just as all of the arrow should be an archer must follow almost parallel paths to hit within the circle of the pupil's eye. When a ray strikes a mirror, it reflects according to the law of reflection. The figure shows that the ray parallel to the principal axis is reflected and crosses the principal axis at point F. So, when a ray strikes the mirror, it's reflected according to the law of reflection. So this figure shows that when the rays come parallel to the principal axis, it will reflect passing by the point F. Okay, so the first law in concave mirror, when the light rays come from the source of the light rays parallel to the principal axis, it will reflect passing by the focal points.
Focal length is the position of a focal point with respect to a mirror along the principal axis.
Image, did you see the focal length? It half to the radius. Yep. So F equal half R. So the R equal the distance, the radius between C and M equal to F. So the F half R. The focal length is a positive for a concave mirror. So the value of the focal length, it will be positive for a concave mirror. Did you see this object? When the objects between these 2 points, C and F, the image of this object, it will be by this shape. How this image is formed? At the beginning, any object will give me 2 rays, one of them parallel to the principal axis and the other one will passing with the focal points. So the first ray, which is parallel to the principal axis, it will reflect passing by focal points, and the other ray, which passing by the focal point, it reflects parallel to the principal axis. The intersection between these 2 reflected rays, it will form the image. So the position of the image in the point of intersection between the reflected rays from ray 1 and ray 2. Okay? So from the concave mirror, the image formed by parallel ray reflected of the spherical mirror with the large mirror diameter and the small radius of the curvature is a disk, not a point. This effect, called a spherical aberration, makes an image look fuzzy, not sharp. Well, I have a rule for the magnification. How to calculate the magnification of the image? According
is a property of spherical mirrors which refers to how much larger or smaller an image is relative to an object.
So the magnification of an object by a spherical mirror defined as the image height divided by the object height is equal to the negative of the image position divided by the object distance. So we can make a sample for the magnification. M equal the height of an image divided the height of an object equal the negative the position of an image divided the position or the distance of an object. So the magnification is negative, which means that the image is inverted compared to the object. Okay?